I'll start over when the recording goes, when the recording starts. Right, so we are recording now. Right, so we want to read a file named temp.txt. Temp.txt has one value in floating point value per line, right? And we want to output the following information, right? The highest temperature, lowest temperature, the day that the highest and lowest temperature was on. This would be assumed that every line represents one day, right? So we're keeping a count of the lines as well. Okay, and we want to get the difference between the highest and lowest temperature and the average overall temperature. But the first thing that we have to do is that we should start off by creating our file pointer so that we can read the file. And what I was saying before was that because of the fact that we know that there is only one floating point value per line, only one floating point value per line, then we can use scanf instead of fget to get the data from the file. But if you use fget, it's just a matter of putting what you read via fget through a function that will convert the string that we the string that we will get when we read using fget. We can use a to f to convert it to a float. All right, let's worry about that in a little bit. Let's just see if we can get the file read. So we go in fopen, and because of the fact that temp.txt and this program, the C file is in the same file, I will not use absolute referencing. I'll just put temp.txt inside of here because they're in the same folder. So the program that is going to be created when I run this code is also going to be in the same folder as this temp.txt file. So it will look for temp.txt in the location that it is. And what do we want to do? We want to open the file for reading. Okay, we want to open the file for reading. So hold a second, please. Yeah. So we want to open the file for reading. So we say fp is equal to fopen temp.txt_r. Okay. You could only do this when you know that the C file and the text file are in the same folder. Otherwise, you are going to have to reference the location of the text file via C:\\\/ the folder that you have it in, \\\, the file that you have it in, the location of the file. Okay? So
it was okay if you had put the reference location.
the absolute location, you mean?
Yeah.
Yes.
Okay,
It's
cool.
okay. Yeah. All right. I'm just too lazy to type out all this because this is in about 5 or 6 folders deep. So, and I know that it's in the same location. Next thing that we have to do is that we have to test to see if it's in the file. All right. So if fp is equal to null, what does that mean? It means that we can say printf file not found. We could printf file not found, do a get char, and do an exit 0. And at this point is always a good point to test to see if it is that the file is there or if the file isn't there. We run it, we don't get the file not found error, so it means that the file is there, right? So I would have had to type out all of this whole long path inside of here, but because of the fact that the exe file and the txt file are in the same folder, it means that I could just simply use referential addressing, right? Or address by reference to be able to locate the file. Okay, so that's the first thing. So the next thing that we could do, and this is how I would go about recording it, is that I would go about first just simply reading and printing out every value inside of the file. Okay, so I will go while n equal to file in the file for FP, while n equal to file in the file for FP, we go, we would say F scanf, right? And we'll have to have a variable to scan this in. And the variable type that we would have is float, right? So we could say float temp. So I would say fscanf from FP, right? I'm reading the data type float, and I want to store it inside of temp, right? Because that's the current temperature that is inside of the file. So once I do that, I could just simply print out to the screen, printf %f \n, and this is really and truly just me testing to make sure that my values for temp are being read from the file. So if I run this, I'm getting the values that were inside of the file, right? So 56 point, so I'm getting some sort of precision issue here because that's not exactly, I have 56.8 and 56.79999 is being read out, right? 47.20001. Okay, so I have some precision issues being dealt with here. See point. If that fixes anything. Right, yes. So it fixes how the information is displayed. Right, or 0.1f. So that it comes out very much like what is inside of the file. Okay. I'm getting that last line reading twice because I have that extra space there. Oh, and you see what happened there? So I might have to go here into my Valdez_C folder, look for temp.txt and remove that in Notepad. All right, because when I had the file open in code blocks, it was always trying to push the the availability of the next line on for me. So I had to go and put it in Notepad. Let me just switch so that you could see my whole screen and see what I would have done there. Okay. So what I did was I went into here and I made sure that in Notepad that the cursor stops here, because of the fact that code blocks is an IDE, it always tries to push you onto the next line to finish. So now reading it, I have exactly what's in my file coming out. So now I have the file. I know that I'm accessing every value inside of here. How do I now start to deal with these things, right? The highest temperature and the lowest temperature, well, the first one read should always be the highest and lowest, and then afterwards we could work out what the highest and lowest is from there, right? And the data the highest temp was on and the data the lowest temp was on, right? So I can have integer, int, right? The current D, the highest D, and the lowest D, right? And actually all of these, I do this as a lazy thing, boy. Let's see if that will work there. Yeah. So I need to say D is equal to 1, highest D is equal to 1, and lowest D is equal to 1. All right. I was trying to declare and assign values all at the same time, but it wasn't happening for me. And then, of course, we could have highest underscore temp and lowest underscore temp. Okay. And when we're reading on day 1, the first temperature that we read, we could say if day is equal to 1, so if this is the first day, right? If this is the first day, what do we want to do? If this is the first day, well, temp is equal, sorry, not temp is equal, but L underscore temp is equal to H underscore temp, which is equal to the current temperature. That I know we can do, right? So set the highest and lowest temperature to the first temperature read. Okay? But if it's not the first day, else, if it's not the first day, you have to check to see if, right, if it is not the first day, then we want to check to see if the temperature is lower than the known lowest, right? And you want to do that for the highest as well, right? So if temp is lower than L underscore temp, then you say L underscore temp is equal to temp, right? Make the current temperature the lowest temperature. Okay, and you will do the same for the highest. You will say if, right, temp, the current temperature is greater than the known highest, H underscore temp. So you will check to see if the current temperature is higher than the known highest. And if it is, then H underscore temp is equal to temp. Right? Set the current temperature to the highest temperature. So we've sorted out the highest and lowest temperature, right? And what about, of course, the days need to move forward. So this needs to say day plus plus down here. So that the next time you read a temperature, right, the next time we read a temperature, it is because of the fact that it's a different day, okay? And if we want to store the day now I have to put my brackets around here because now I'll have more than one value inside of this if statement. All right, we could do the same thing here in terms of record what day the lowest L underscore D is equal to D. Right, save the day that the lowest was found on. And so we said here that we set the first day and the highest day and the lowest day to 1 because the first temperature will always be the highest and the lowest, and because there's no others to compare to, right? And we have high underscore day being equal to day in this instance. So once you find a higher temperature, set the day to set the highest day to the day with the highest found temperature. All right? And so we found out, basically, we've done the highest temperature and the days that the highest and the lowest was, right? If you want, we could test that out right at the bottom here. So instead of
No, sorry
Yeah.
for interrupting, but is it supposed to have a minus sign in front of the day in
Oh
highest?
no,
Okay.
that's a typo on my part. So thanks for that.
Okay.
Right. Right. So what we could do is that we can now print out and after the while loop is finished, right? So we could always say end while here. And we could go and we could print out part. We don't have to do all at the same time. You could do part and then test and see how that's going, right? You could go %sign D, right? D %sign D had the lowest temperature of %sign F, right? And copy that and change this to highest, and then we could put in what we reference in, right? We could put L underscore D here, and then copy L underscore temp here. And we could do the same for here. We could put H underscore D here, and we could then put H underscore temp here, right? And these would print the highest and the lowest temperatures after everything was read. Notice that this is outside of the for loop, the while loop. So you have to finish reading everything before you can. You have to finish reading everything before we could print out that a specific day had the highest or lowest temperature. All right. So let's run it and see. We compile. We have. Sorry, I missed my temperature there. Right. And so we say this, day 4 had the lowest temperature of 27.79 and day 5 had the highest temperature of 101.5. Okay. And again, we could put the 0.1 there and the 0.1 here to get a little more precision and to make it look like exactly what was in the file. Right? Let's open the file and see 27.8. This is on the 1, 2, 3, 4th line, and 101.5 was on the last line. So let's put 22.6 here, right? Which is now the new lowest, and test it again. Right, day 7 had the lowest temperature. Okay. And now we want to get the difference between the highest and the lowest temperature and the average overall temperature. So for the average overall temperature, we need to have a temperature sum, which would be starting off at 0. But as you read the temperature, you could say temp underscore sum, right, is plus equal to temp. Okay, and this will accumulate, right? Accumulate the temperatures for finding the average. And we need to have a temp underscore AVG, so that at the end we could see temp underscore AVG is equal to what? Temp underscore average is going to be equal to temp underscore sum divided by the amount of days minus 1, right? Because you have to remember that at the end here, we always kind of carrying day forward. So at the end, we'll actually end up on the next day. So we have to carry it back to get an accurate count of how many days we had. Okay? Because they didn't start at 0, they started at 1. So if you had 3 lines before you finished your code, they would end up as 4. So in this case, to find the actual average, right? To find the actual average, we will end up having to minus 1 day from the total amount of days. Okay? So, and so we could say, okay, printf, common P, the average temperature is %F, right, 0.2F, where we could see temp underscore average. And the last thing that we say is print the difference between the highest and the lowest temps were $0.2.1 F, right? And that would be a sum that we could put inside here. We could say H underscore temp minus L underscore temp. Once we get that, we could put a \n here, compile, and hopefully everything. So the average temperature is 54.24, and the difference between the highest and lowest temps was 78.9, which we could calculate from this here. Okay, and that would be our solution. Any questions on this? Any questions on this? No?
So,
Yeah.
so I know I thought that use like functions and things to solve this because I was doing like a function.
No. Why would you think that? The question is straightforward.
I was thinking also.
Don't overthink. Do not overthink. Overthink is the enemy in programming, right? Because you'll end up with an over-engineered solution. So it's 10:15. I still want to let us get our break. Let's take a 10-minute break. And let's take a 10-minute break, and then we would resume after, okay? So I'm going to pause this recording here.